Welcome to today's classes. Dear children, today we can discuss the theory about differential equation. All of us know what is differential equation. An equation which contains differential coefficients like dy by dx plus x square equal to 5 is a differential equation because differential coefficient dy by dx is present. It can be d square y by dx square or dx by dy, d square x by dy square, even dx by dy minus sin x equal to 7 is a differential equation. Now, for any differential equation, we can consider order. Then we can go for degree if it exists. What is meant by order of a differential equation? Order means highest order derivative present in the differential equation. Like d square y by dx square minus x dy by dx equal sin x. Is very clear, this is a differential equation. Here first order derivative is there, second order derivative is there. So first and second comparing, second is the highest. So order of this differential equation is 2. So order of the differential equation is 2. What about degree? Degree of a differential equation we can define only if the differential equation is in the form of a polynomial. All of us know polynomial will contain finite number of terms. If infinite number of terms are there, then degree cannot be explained. Degree is not existing. So, this differential equation is in the form of a polynomial because dy by dx, d square y by dx square, only two terms are there. The number of terms are finite. So, finite number of terms are present means that is considered as a polynomial form. So, here order deciding term is d square y by dx square. Once order is decided, that term's power, the highest power of that term is. So, this term nothing is written means power is considered as 1. So, that 1 is taken as degree. So, degree of this differential equation is 1. So, order will be always positive integer. Degree will be always positive integer if it exists. So, order and degree are always natural numbers. Now, while finding order degree problems, they can ask questions like this. Let me write an example. D square y by dx square plus 1 under the square root equal to dy by dx. How to find order and degree? We know to find differential equation order degree, no root form, no rational form should be present with the differential equation. It should be converted into a polynomial form if possible. So here, whenever you write a polynomial form, standard form of a polynomial is a0, a1x, a2x square plus etc. an x power n. So all these power of x 1, 2, 3 up to n are positive integers. So this is a polynomial because it is finite number of terms are there. So here the power of this entire LHS part is root, means power is 1 by 2. That should not be present. So to cancel the square root, we can square on both sides. Squaring on both sides, square root will cancel. So guys, once square root is cancelled, what is the remaining? D square y by dx square plus 1 equals dy by dx whole square. So this is in the form of a polynomial. There is no rational power, there is no negative power, nothing. So first order is there, second order is there. First we have to fix order. So first order, second order, order is, this is the term deciding order. So order O is 2. Once order fixed, that term only giving degree, no other term. So what is the power of that term? The power of that term is 1. So degree is again 1. So order is 2, degree is 1. Let us consider another example. 3x minus dy by dx plus 1 dy by dx equals 7. How to find order and degree of this differential equation? Here the problem, the dy by dx is in the denominator. Once it comes to top, numerator, we can write dy by dx powered by minus 1. That should not be there while calculating order degree. So what we can do is multiply throughout by dy by dx. This is the term we are using to multiply because this term should be removed from the denominator. So multiply by dy by dx. That means each term we are multiplying 3x multiplied by dy by dx minus dy by dx into dy by dx. How much? Dy by dx whole square. Don't say d square by dx square. This dy by dx whole square plus 1. Right side 7 become 7 into dy by dx is perfectly a polynomial form. First order powered by 2, again first order. So all these are first order. Out of that, highest power is 2. So order is 1, degree is 2. Order is 1, degree is 2 for this differential equation. Next, variety of question. Let us see a differential equation. Say 3 plus d square y by dx square whole powered by 3 by 2, which is equal to dy by dx whole powered by 2 by 3. This is not a polynomial form because rational powers are present. Now, what we can do? Such cases when different powers are present, when square root only present, we can square. But here squaring is not possible because here 3 by 2, here it is 2 by 3. Such cases, the LCM of these two, denominator quantity 2 and 3, LCM of 2 and 3, that is nothing but 6. Use the 6 to power on both sides. So we can write 3 d square y by dx square, that is powered by 3 by 2. That has to be powered by 6. Powered by 6. That is equal to right side dy by dx whole power 2 by 3. That has to be powered by 6. 2 and 6 cancelled to 3. 3 will make it 9. So 3 plus d square y by dx square whole raised to 9 equal 3 and 6 cancelled to 2. Become dy by dx whole raised to 4. 2 power 2. So here first order is there, second order is there. Now once you expand this using binomial theorem, because power is 9, you will get a term where you can find d square y by dx square powered by 9. So here we can take order as 2, order, degree as 9. So for this question, what is order? Order is 2 and degree is 9. This is the way these kind of questions we are discussing. Okay. Next, there are certain cases where order and degree finding is not so easy. Order degree finding cases which contains sine of say dy by dx or sine of d square y by dx square, sine of dy by dx, d square y by dx square, etc. Even with the cos of the same thing, cos of same thing, tan of same thing, all these are trigonometric functions, sine, cos, tan, cosec, sec, everything. Even logarithm followed by the same quantities, e power followed by the same quantities. If these many terms are present with one more dy by dx or d square by dx square, such cases degree does not exist. That means what I said, these many terms followed by some other differential coefficients present means degree will not exist, because all these sine, cos, tan, log, e power, all these are infinite series. They will give infinite terms. Then infinite terms are present means that cannot be treated as a polynomial. A polynomial will always contain a finite number of terms. So these many terms will not make it polynomial. So degree will not exist, but order will exist. Example, let us see. Dy by dx plus sine of d square y by dx square equals 5. I set sine of these many terms followed by some other differential coefficient. Such cases, degree will not exist. Order will be highest order. See here first order, here second order. So order is 2, degree not existing, degree not defined, degree not defined. Suppose the question is, that should be very carefully treated, sine d square y by dx square followed by a where a is a constant, whether order and degree is existing. Remember my statement, sine of d square y by dx square followed by some other dy by dx or d square y by dx square, degree is not defined because that cannot be a polynomial. But here degree can be defined because after sine of d square y by dx square, no other dy by dx or d square y by dx square is present. Can you find any other dy by dx? No. So you can write this example as sine goes to right side becomes sine inverse a. This is a constant. This is a constant. Now this is a perfect polynomial form. Order is 2, degree is 1 because its power is 1, degree is 1. So by simply seeing a sine of d square by dx square, don't decide, degree is not defined. So this followed by one more dy by dx is that degree will not be there. If nothing is there, degree as well as order will be defined. Let us see another example like this. Like log of say dy by dx plus 1 is equal to 3x plus 4y, whether order and degree is there or not. Like what I said, log of dy by dx, then there is no other dy by dx or differential coefficients, so degree is there. Here base is c, we know how to convert logarithm to exponential. Log a to the base b equal to c means a equal b power c you can write. If you follow this rule, I can write dy by dx plus 1 equal e power 3x plus 4y. E power 3x plus 4y, not a problem. This is not deciding our order or degree. So this is a polynomial. This is a polynomial form. Polynomial form only. Order is 1. Its power, degree is 1. Order and degree is there for this differential equation. Next, if e power dy by dx equal to 5, now we can consider order degree. In what way? Take log on both sides. As I said, there is no other dy by dx or differential coefficient. So when you take log of e power dy by dx equal to log 5, here one more base is therefore, then we know as per the property of the logarithm, log of a power n will come in front, n into log of a to the base e. So here dy by dx will come in front, followed by log e to the base e. Log e to the base e is 1 equal to log 5. So take it as 1. So dy by dx equal to log 5 is perfectly polynomial form. This is a polynomial. This is a polynomial. So order is there 1. Since its power is 1, degree is also 1. So these are some tricky questions where order degree questions you may get confused. So don't get confused henceforth, where dy by dx, here power is 1, here also power is 1. So in log and e power, if you are able to convert into polynomial form, order as well as degree will be clearly existing. Good. Let me write dq y by dx cube plus sine d square y by dx square equal to x e power x. Is it contains any degree? No, because sine d square y by dx square followed by another differential coefficient means degree will not exist. So order out of this highest is 3. Order is 3. Degree is not defined. Degree not defined. Degree is not defined. Suppose dq by dx cube is here and d square by I am changing the question. Suppose d square by dx square plus sine d cube y by dx cube equal to e power x. Then order, second order is there, third order is there. Here also order is 3 only and degree not defined. Degree not defined. Degree not defined will be the answer for both the cases. Okay. Now, for solving differential equation, we have different methods. One is type 1 linear differential equation. Linear differential equation. The standard form of a linear differential equation is dy by dx plus py equal to q, where p and q are either constants or functions of x. Functions of x. This differential equation, you can remember, if dy by dx, y is present, here single y will be available. It's if, integrating factor, e power integral p dx. Because we are going to differentiate as well as integrate with respect to x. Dy by dx, differentiating with respect to x. So the same dx will come over here. This is called integrating factor. While calculating integrating factor, remember e power log of f of x will be always f of x. Like e power log of x will be x only. E power log of say sin x will be sin x only. So this result will be useful while calculating if in many cases. Then general solution will be y into if equal to integral q into if followed by dx. At the end, we can put a constant of integration c. It can be either in the right side or in the left side. This is the general equation of a differential linear differential equation. Another type of linear differential equation is this way we can write. This is first type, this is the second type. Dx by dy plus p1x equal q1. X means here one x variable will be there. Here if will be e power integral p1 with dy. Differentiating with the dy, y means integrating with y. Its solution, general solution, x into if equal integral of q1 into if dy with constant of integration. This will be the general solution of the differential equation. Now, with the different questions we can solve. While solving some word level questions, you can expect the slope of a tangent is equal to its sum of the abscissa and ordinate. What is meant by slope of tangent? Slope of tangent, mathematically we can represent dy by dx. Slope of tangent is nothing but dy by dx. Abscissa, abscissa means x coordinate of the point. Ordinate, ordinate means y coordinate of the point. These are the two important points you are supposed to remember. Next, the particular solution of a differential equation will not carry any arbitrary constant. So, number of arbitrary constants in a particular solution is 0. Number of constants, arbitrary constants in the general solution will depends the number of arbitrary constants what is there in the question. For example, if y is equal to mx plus c, here m and c are arbitrary constant. This is the solution. So m and c are arbitrary constants means this differential equation of this y is equal to mx plus will carry order 2. So the order of the differential equation decides number of arbitrary constants present in the solution. So y is equal to mx. How many arbitrary constants are here? Only one arbitrary constant is there. So the order of the differential equation of the solution will carry order 1. The differential equation of this solution will carry order 2 because order decides number of arbitrary constants. So general solution will carry arbitrary constants, same number of arbitrary constants, but particular solution will not carry any arbitrary constants. Their c value we are calculating and evaluating, substituting that c value. So there is no arbitrary constant. Next, homogeneous differential equation. The standard form of a homogeneous differential equation. An equation f of x comma y, a differential equation in the form of f of x comma y is said to be a homogeneous differential equation if I replace x by lambda x and y by lambda y, so that I am getting lambda power n followed by f of x comma y. If I am able to write like this, where lambda is a constant which is not equal to 0. This lambda power n is called degree of the homogeneous function. Degree of homogeneous function. Degree of homogeneous function. So f of x comma y is said to be a homogeneous function if I replace x by lambda x and y by lambda y. If lambda raised to n is coming, then it is a homogeneous function of degree n. A homogeneous function I can represent in another form. F of x comma y equal to x power n followed by g of y by x. This is a homogeneous function of degree n. Or it can be y raised to n followed by x by y. So x power n means denominator x. y power n means denominator y. So both the ways we can express homogeneous function. Then degrees n. Now, what is the difference between homogeneous function and homogeneous differential equation? I started with homogeneous differential equation. So far, I didn't explain. So, a homogeneous function becomes homogeneous differential equation if the degree n is equal to 0. See, f of x comma y is equal to x power n followed by g of y by x becomes a homogeneous differential equation if n is equal to 0, degree is equal to 0. If degree is equal to 0, then just y by x will be present because x power 0 is 1. So for all homogeneous differential equation, degree is equal to 0. If degree is other than 0, it is not a homogeneous differential equation. We can call it as homogeneous function. Okay. So f of x comma y. Let me give an example. F of x comma y is equal to sin y by x. Is it a homogeneous differential equation or a function? You replace x by lambda x, lambda y, sin of y is lambda y, lambda x, lambda lambda cancelled. You can take lambda raised to 0 sin of y by x. Lambda raised to 0 means 1 only. It won't make any difference in these two. So this is a homogeneous differential equation. What about f of x comma y is equal to sin x plus sin y? Is it a homogeneous differential equation? You have to check. Replace x by lambda x, lambda y. Then you will get sin lambda x plus sin lambda y. We cannot take lambda outside. This lambda is trapped with sin function. So you cannot write this as a lambda raised to something. You cannot write. You are not able to write like this. So this is not a homogeneous function. This is not a homogeneous differential equation. But this is a homogeneous differential equation because it is able to write lambda raised to 0 followed by the same question. So this is lambda raised to 0 followed by the same question. So this is a homogeneous differential equation. But sum of the terms is not a homogeneous function at all. So it is not a homogeneous differential equation also. So this is the way homogeneous differential equation we are discussing. To solve homogeneous differential equation of the form, say dy by dx equal to g of y by x, we have to put y by x is equal to v or y is equal to vx. If it is dx by dy, then h of x by y, you can see dy by dx if you are writing, your y by x will come. Dx by dy if I am writing, x by y will come. We have to put x by y is equal to v or x is equal to vy. Then we have to find differential coefficient of y as well as differential coefficient of x. Then we can find differential equation solving method. So these are the important points regarding MCQs for differential equation. So please revise all these points. Thank you.